Welcome to the Infinity Process Platform tutorial. In this instance of the tutorial, we will model a helpdesk process, define complex data structures, and assign these data structures to influence the control flow of the process. This tutorial uses the helpdesk process example that you can find in the Infinity Process Platform cheat sheets within Eclipse or in the Infinity Process Platform documentation. We pick up where we left off in the previous tutorial when we set up our development environment and created our first project. We created our support case project environment and set up Apache Tomcat as our runtime environment. Now it is time to create our first process definition. For that, we go to File, New, Infinity Process Model, and we want to call our new process model Support Case. We have to pick a folder where it is supposed to be stored. We'll pick our Support Case project folder, click OK, and finish. Now we have our development environment here, and on the left-hand side I see the outline of all the elements that I have modeled or that come out of the box in a fresh XPDL process file. You will see that the support case is named supportcase.xpdl. XPDL stands for the XML process definition language, and that is the file format that Infinity uses to store its process models in. We have one process definition open by default. That's our process definition 1. And I want to rename this process definition, so I'm just going to right-click on this, choose Properties, General, and I will rename this process definition Support Case Process. But you can name it anything you like. OK. Each process definition has a default diagram associated with it, and you can create additional diagrams for each process. You can also create additional diagrams at the model level, which is the XPDL level. Having a diagram at the model level is useful to create, for instance, an organization structure that you share across multiple process definitions. And you can have multiple process definitions within one model, which is useful if you have a sub-process that you want to reuse across multiple processes, or if you have processes that share the same resources, such as the same data structures, the same application definitions, or that are executed within the same organization structure. So let's start creating our process definition. We have a couple of activities that need to be created, so I'm going to choose my default diagram, Activities, and my first activity is an application activity. It's fully automatic. It's just used to initialize the data set for the trouble ticket that I'm going to use. I'm placing it on the canvas. I can click on the label and change the name to init data. When you model a process and when you model individual activities, it is a good idea to label these activities in the form verb object. So give it an action first and then the object that the action is performed on next. If you need multiple verbs to describe an activity, it means that you're probably grouping things together that should be separated. And if you don't have one object that you're working on but multiple objects, again, you might be at a different level of abstraction than you should be, and you may need to refine this step a little further. So this is a good practice. The next few steps in our process are manual steps. So I'm going to choose Manual from the Activities menu here, and I'm going to hold down my Control key so I can place multiple steps on the canvas without having to go back to my menu. So I placed 3 manual activities here. The first one is called Create Case. This is where an employee of our company picks up the trouble ticket and creates a record for it. The second step is called Analyze Case. That's the step where a technician actually looks at the case. And the third step is called Deliver Patch. That's where we send a solution back to our customer. Now, in certain cases, we might not be able to provide our customer with a solution, for instance, if the problem hasn't been caused by our product. So we create an application activity or an automated activity here that we call notify customer. And we're done with the basic number of steps that we have in our process. Now it is time to connect these steps. So from init data, I press the C key as in Charlie, and I draw a connector to create case. I could have also picked connect here from my tool palette, but using the C key is typically faster. Now I want to connect create case, hit C with analyze case, and I want to connect analyze case with C with deliver patch. Now, after analyze case, there should be a choice in the process. Either I deliver the patch or I notify the customer. So I'm going to right-click on analyze case, and I can define split behavior. That is, if there is a split in the process after the analyze case step. This split can either be an XOR split, exclusive OR, meaning that out of the outgoing flows only one will be chosen, or it can be an AND split, which means that all of the outgoing flows will be followed. The logic that I want here is an XOR split. Only one of these following steps will be chosen. Now you see a gateway has been placed in between the control flow, which has been broken up. And now I can choose this gateway. I can press the C key as in Charlie, and I can go to notify customer so that I have a choice in my process. Now in certain cases, I may want to loop back. I may want to go back to analyze case to reanalyze or to send the case to a technician that is better equipped to solve the customer problem. In order to do that, I need a join before my analyze case step. This join means that I take the flow from create case and the flow that may loop back from this decision point, and I merge them together so that either one or the other will arrive at the analyze case step. To design a join, I do the same thing that I did to design the split. I right-click on analyze case, I define the join behavior, and I choose an exclusive OR join. Now I have a gateway that has been placed here, and I connect both gateways. Select this one, press the C key, and draw a connector up to the other gateway. May look slightly iffy at first. When you click on the link, you can select the small black dots and modify the routings. So this is it. This is our initial process structure. In order to make this process work, we will need to provide it with some logic that allows the workflow management system to make a decision when it reaches this gateway, which way to go. At the moment, the workflow system will simply follow the transition that has been created first, but that's not the logic that we want. We want to make a decision based on the properties of the case. So we have to create a data structure for the case. Workflow data is typically represented through a data object that you can see here in the tool palette. And there are certain predefined data objects, which are here in my outline, that I could use. But I want to create a custom data object. Not only that, I want to create a structured data object. What you can see in my data structures here, I could choose documents or folders of documents. I can choose certain Java objects such as an entity bean. I can choose XML documents, or I can choose primitive data. But what I need for this case is I need a trouble ticket. And this trouble ticket is a structured data type. To set up a structured data type, I have an option structured types here in my support case tree. So I'm going to right-click on this, and I say I want a new composite type. A new composite type is like a data object in an object-oriented paradigm. It's a collection of either primitive data types or other composite data types. So let's create a new composite object. Let's double-click on this, and let's name it product. Okay. And let's define this type. This type contains all the information about the product that the customer is calling about, such as the product name. So I can just click on new, type in name, and it auto-populates each new element as a string with a cardinality of exactly 1, but I could choose this to another data type, and I could choose I could change the cardinality to reflect the logic of an entity relationship diagram or a relational data model. But I want to leave it at exactly 1. So we want the name, we want a synopsis, which is a description of the problem that is being reported. We want the state of the solution, and we need a description of the analysis that the technician has performed. Each of these are string data types. The cardinality for each is exactly 1. Okay, we've defined our structured data type product. But information about the product itself is not sufficient. We also want information about the customer. So we create a new composite type, double click on it. Let's call this one customer. And add a bit of information. So our customer has an ID, and the identifier for the customer is an integer data type. The customer has a name, which is a string. The customer has an email address, which is a string. And the customer is linked to a product, and this product is our product data type that we've just defined. So if I scroll down here, I can select the product data type, the complex data type that I've just defined. So as you can see, you can define nested data types for further reuse. Let's say OK. I've got my 2 structured types here. Now I can't just take my structured types and drag them over onto my canvas. That is not allowed. I actually have to create a data container for these types. So what I want to do is I want to create a new data object. My new data object is a structured data object. So it's at the bottom of this list. I'm going to double click on this. I'm going to call the structured data object support case data. And it points at a structured data definition. In this case, it points at the customer data definition. We can explode this here to see what data is actually included in this. So I've got my names, my types, my cardinality to make sure that everything is exactly as I would like it to be. Okay, we've created our support case data type. And now as you can see, the support case data type is correctly defined. It does not have a little red X associated with it, as opposed to our support case process and the associated activities that we have defined. This is caused by errors that are associated with our activities because they are not yet fully defined. For example, our manual activities have not yet been assigned to performers, and our application activities do not have definitions for applications associated with them yet. This needs to be fixed. Only when all of these problems have been solved will the red X at the support case process level go away. So whenever you see a red X in your outline on the left side, you know that there's something wrong underneath, and if you fix all the things underneath, then the problem at the higher level will most likely go away. So I'm going to take my support case data element, and we'll drag this on the canvas here. You can drag and drop every element that you have on the left side in your outline onto the canvas, and you can do that multiple times. This does not necessarily duplicate the object, but it gives you multiple representations of the same object on one drawing page, which allows you to create cleaner models. So we have our support case data element on the canvas, and now we need to define the input and output relationships between the activities and this data element. Now our support case data element is initially created and populated in the init data step, so it is actually the output of the init data step. In order to show this, I pick the init data step, press C and point to my support case data. So support case data is the output of the step. Now I pick support case data, I press C, and I draw a line to create case to signify that the support case data is input for the create case step. It is also input for the analyze case step. It is input for the deliver patch step, and it is input for the notify customer step. I also have a relationship between create case and analyze case and support case data in the opposite direction, meaning both of these steps can update the information in support case data. So I choose create case, hit C, and draw a line back, and now you see that this arrow here points in both directions, meaning that support case data is both input and output for create case. And the same thing goes for analyze case, hit C, and point back to support case data, and the line between analyze case and support case data points in both directions. So as you can see, support case data now is output of init data. It's read and written from create case, it is read and written from analyze case, and it is only read by deliver patch and notify customer. To set up the decision logic that defines which way we follow from the gateway, we have to double click on our control flow. By default, the condition expressions for every control flow in your process model are set to true, which means that the control flow will be traversed. But in our case, we want to make this conditional based on the state of the solution that we've generated. So our condition expression changes from true to a reference to the data object that we're referring to. Now the data object that we're referring to, I'm going to move this to the side a little bit, is our support case data. So we type support case data dot, and up pops a dialog box or a little pop-up menu that lets us browse through the data elements in our support case data. We want to go to our product, so I'm double clicking on this. We hit dot again, and we can select state, which is the data element that we want. And we want to say that this equals R for rejected. So in case we have decided that the problem cannot be solved and the case should be rejected, I'm going to click OK here. Our control flow will go to notify customer. We will send a message to the customer that we could not solve the problem. If we could solve the problem, let's double click on this control flow. Again, we have to change the condition expression to support case data. And one thing you will notice is that I'm not using any spaces when I type in this field, because I'm referring to the identifier of the support case data element. So support case data dot product dot state equals, which is two equal signs next to each other, C for closed. Or you can enter any value that you like, just make sure you remember it. So this is set to a parameter. If the state of our case is set to the letter C, as in closed, we will deliver a patch to the customer. And now for the loopback, I double click on this control flow. I'm going to set this condition to otherwise. Otherwise is a condition, or otherwise is an expression that evaluates to true if none of the other control flows here evaluate to true. So if this one fails and this one fails, then this control flow will be followed. And that's it. That's our data definition, and that's the association of our data with a control flow. So we have defined our helpdesk process, we have defined a complex data structure with two structure types that are nested in each other. We have defined the relationships between our complex data structure and our activities, and we have used elements of this complex data structure to make our control flow decisions. Now I want to save my support case. This concludes the first part of our Helpdesk process tutorial. In the next part, we will create an organization structure around this process and assign applications to the automated activities.